to the series of e-learning modules on practical. Here, given the situation, we try to define the random variable and identify the distribution of that random variable and find the probability of the event. We also fit a distribution to the given frequency distribution. By the end of this session, you will be able to find the probabilities of an event after identifying the distribution, fitting a given distribution for the given frequency distribution when parameters are known or unknown. A computer has 4 disks numbered 0, 1, 2 and 3, one of which is chosen at random on boot to store temporary files. Find the probability that an odd numbered disk is chosen. Let X denote the number on the chosen disk. Since the disks are numbered serially 0, 1, 2 and 3, all the disks have equal chance of being selected. Hence X is a discrete uniform distribution with n is equal to 4. Therefore, the probability mass function is given by P of X is equal to 1 by n. X take values 0, 1, 2 and 3. Since disk is numbered from 0 to 3, we have 2 odd numbers, 1 and 3. Therefore, probability that odd numbered disk is chosen is equal to P of X is equal to 1 plus P of X is equal to 3 is equal to 1 by 4 plus 1 by 4 is equal to half. The incidence of an occupational disease in an industry is such the workers have 25% chance of suffering from it. What is the probability that out of 5 workers, at the most 2 contract the disease? Let X denotes the number of workers contracting the disease among 5 workers. Then X is a binomial variate with parameters n is equal to 5 and P is equal to 25% is equal to 0.25. The probability mass function is P of X is equal to NCX into P power X into Q power n minus X. X take values 0, 1, etc. n. That is P of X is equal to 5Cx into 0.25 power X into 0.75 power 5 minus X. The probability that at most 2 workers contract the disease is P of X less than or equal to is equal to P of 0 plus P of 1 plus P of 2 is equal to 5C0 into 0.25 power 0 into 0.75 power 5 plus 5C1 into 0.25 power 1 into 0.75 power 4 plus 5C2 into 0.25 power 2 into 0.75 power 3 is equal to 0.2373 plus 0.3955 plus 0.2637 is equal to 0.8965. 7 unbiased coins are thrown 128 times. In how many throws would you find at least 3 heads? Let X denote the number of heads obtained in a throw of 7 coins, and hence X is binomial variate with parameters n is equal to 7 and P is equal to half. Hence probability mass function P of X is equal to NCX P power X into Q power n minus X, where X take values 0, 1, etc. n. That is P of X is equal to 7Cx into half power X into half power 7 minus X. Here, the frequency of tosses with at least 3 heads is required to be found. Hence, first we find the probability of getting at least 3 heads, and then we multiply this probability by the total frequency. Hence, probability that at least 3 heads appear is equal to 1 minus probability that less than 3 heads appear. is equal to 1 minus p of 0 plus p of 1 plus p of 2, substituting the values of x in p of x and simplifying, we get 1 minus 1 by 128 plus 7 by 128 plus 21 by 128 is equal to 1 minus 29 by 128 is equal to 99 by 128. Therefore, the number of tosses resulting in at least 3 heads is given by n into probability that at least 3 heads appear is equal to 128 into 99 by 128 is equal to 99. Binomial distribution with parameters n is equal to 7 and p, the first and second terms are 0.0824 and 0.2471 respectively. Find p. The probability mass function of binomial distribution is given by p of x is equal to 7cx into p power x into q power 7 minus x, where x take value 0, 1, etc. 7. Here p of 0 is equal to 7c0 into p power 0 into q power 7 is equal to 0.084 and p of 1 is equal to 7c1 into p power 1 into q power 6 is equal to 0.2471. Therefore, by taking the ratio of above probabilities, we get p of 0 by p of 1 is equal to q power 7 divided by 7 into p into q power 6 is equal to q by 7 into p is equal to 0.084 by 0.2471, implies 1 minus p by 7p is equal to 0.3335. That is 1 minus p is equal to 2.3345 into p, implies p is equal to 1 by 3.3345 is equal to 0.2999. Thus, probability mass function is given by p of x is equal to 7cx into 0.2999 power x into 0.70, 01 power 7 minus x, where x take values 0, 1, etc. 7. 5 coins are tossed 3200 times. Find the frequencies of the distribution of number of heads and tabulate the result. Let x is the number of heads obtained in a toss of 5 fair coins. Then x is a binomial variate with n is equal to 5 and p is equal to half. The probability mass function is p of x is equal to 5cx into half power n, where x take values 0, 1, etc. 5. The frequency function is ex is equal to n into p of x is equal to 3200 into 5cx into half power n. Now, by substituting the values of x as 0, 1, 2, etc. 5, we get expected frequencies E0, E1, E2, etc. E5. Hence, the theoretical distribution of number of heads is given in the following table. A survey of 100 families, each having 5 children, revealed the following distribution. Fit a binomial distribution for the given data. Let x denotes the number of male children in a family having 5 children. Here, n is equal to 5. The parameter p has to be estimated from the given data. For this, the mean of the data is equated with the theoretical mean. The mean of the data is x bar is equal to summation f into x by n. By substituting f, x and n and simplifying, we get 2. Thus, n into p is equal to 2 implies p is equal to 2 by n. Substituting n is equal to 5. we get P is equal to 0.4 and Q is equal to 1 minus 0.4 is equal to 0.6. Thus, probability mass function is P of x is equal to 5cx into 0.4 power x into 0.6 power 5 minus x, where x take values 0, 1, etc. 5. First expected frequency is given by E0 is equal to n into P of 0 is equal to 100 into 0.6 power 5 is equal to 7.776. Now, instead of using the direct probability mass function, we can use recurrence relation to find the expected frequency. Ex is equal to n minus x plus 1 divided by x into P by Q into Ex minus 1. That is, Ex is equal to 5 minus x plus 1 divided by x into 0.4 by 0.6 into Ex minus 1 is equal to 6 minus x divided by x into 2 by 3 into Ex minus 1. Putting x is equal to 1, 2, etc. 5, we get E1, E2, etc. E5. We write observed and theoretical distribution in a tabular form. Expected frequencies are approximated such a way that the total comes to 100. On an average, a typist makes 3 mistakes while typing one page. What is the probability that a randomly observed page is free of mistakes? Among 200 pages, in how many pages would you expect mistakes? Let x denote the number of mistakes in a page. Then x is a Poisson variate with parameters lambda is equal to 3. The probability mass function is given by P of x is equal to e power minus lambda into lambda power x divided by x factorial is equal to e power minus 3 into 3 power x divided by x factorial, where x take values 0, 1, 2, etc. infinity. Probability that a page is free of mistakes is equal to P of 0 is equal to e power minus 3 into 3 power 0 divided by 0 factorial is equal to e power minus 3 is equal to 0.0498. To find number of pages among 200 pages, expected mistakes, first we find probability that a page has mistake. Probability that a page has mistake is equal to 1 minus probability that a page has no mistakes is equal to 1 minus 0.0498 is equal to 0.9502. Therefore, among 200 pages, the expected number of pages containing mistakes is n into probability that a page has mistakes is equal to 200 into 0.9502 is equal to 190. 2% of the fuses manufactured by a firm are expected to be defective. Find the probability that a box containing 200 fuses contains 3 or more defective fuses. 2% of the fuses are defective. Therefore, probability that a fuse is defective is 0.02. Let x denote the number of defective fuses in the box of 200 fuses. Then x is a binomial variate with parameters n is equal to 200 and p is equal to 0.02. Here p is very small and n is very large. Therefore, x can be treated as Poisson variate with parameter lambda is equal to n into p is equal to 200 into 0.02 is equal to 4. The probability mass function of the distribution is given by P of x is equal to e power minus lambda into lambda power x divided by x factorial is equal to e power minus 4 into 4 power x by x factorial, where x take values 0, 1, 2, etc. infinity. Now let us find the probability that a box has 3 or more defective fuses is equal to 1 minus probability that a box has less than 3 defective fuses is equal to 1 minus p of 0 plus p of 1 plus p of 2 is equal to e power minus 4 into 1 plus 4 plus 8 is equal to 1 minus 0.2379 is equal to 0.7621. For the following data regarding births occurring in a hospital, fit a Poisson distribution. Let x denote the number of births occurring in a hospital. Then x is a Poisson variate. The parameter is lambda is equal to x bar is equal to summation f into x by n. By substituting x, f and n as sum of frequencies and simplifying, we get 1.2. The probability mass function is e power minus 1.2 into 1.2 power x by x factorial, where x take values 0, 1, 2, etc. infinity. The frequency function is given by Ex is equal to 50 into e power minus 1.2 into 1.2 power x by x factorial, where x take value 0, 1, 2, etc. E naught is equal to e power minus 1.2 is equal to 15.06. The theoretical frequencies are obtained by using the following recurrence relation. Ex is equal to lambda by x into Ex minus 1 is equal to 1.2 divided by x into Ex minus 1. Hence, by substituting x is equal to 1, 2, etc., we get E1, E2, etc., and we write these in the frequency table as follows. The theoretical frequencies are approximated in such a way that the total comes to 50. If the probability that a target is destroyed on any one shot is 0.5, what is the probability that it would be destroyed on 6th attempt? Let x denote the number of failures before the first success, which is destroying the target in this problem. Therefore, x follows geometric distribution with parameter p is equal to 0.5 and the target is destroyed on 6th attempt. That is, there are 5 failures. The probability mass function of the distribution is given by p of x is equal to q power x into p, where x take values 0, 1, 2, etc. and p lies between 0 and 1. We have p is equal to 0.5 and q is equal to 1 minus p is equal to 0.5. Probability that target is destroyed on 6th attempt, that is 5 failures, is equal to p of x is equal to 5 is equal to 0.5 power 5 into 0.5 is equal to 0.5 power 6. Item is produced in large numbers. The machine is known to produce 5% defectives. A quality control inspector is examining the items by taking them at random. What is the probability that at least 4 items are to be examined in order to get 2 defectives? Let X denote the number of defective items produced by the machine, and the quality control inspector need to get 2 defective, for which he need to examine at least 4 items. Hence X has negative binomial distribution. The probability mass function is given by P of X is equal to X plus R minus 1 CR minus 1 P power R into Q power X, where X take values 0, 1, 2, etc. and P lies between 0 and 1. If 2 defectives are to be obtained, it can happen in 2 or more trials. The probability of success is 0.05 for every trial. Hence required probability is P of X is equal to 5 plus etc. is equal to 1 minus P of X is equal to 2 plus P of X is equal to 3 is equal to 0.05 square plus 2 into 0.05 square into 0.95 is equal to 0.995. A taxi cab company has 12 ambassadors and 8 Fiats. If 5 of these taxi cabs are in the shop for repairs, an ambassador is likely to be in for repairs as a Fiat, what is the probability that at least 3 of them are ambassadors? Let X denote the number of ambassadors come for repair. Hence X has hypergeometric distribution with parameters n is equal to 12 plus 8 is equal to 20. M is equal to 12 and n is equal to 5. Therefore, probability mass function is given by P of X is equal to mcx into n minus mcn minus x divided by ncn, where x take values 0, 1, etc. Minimum of m and n is equal to 12cx into 8c5 minus x divided by 20c5. Therefore, the required probability is given by probability that there are at least 3 ambassadors is equal to P of X is equal to 3 plus P of X is equal to 4 plus P of X is equal to 5 by substituting value of X in P of X and simplifying, we get 0.3973 plus 0.2554 plus 0.0511 is equal to 0.7038. Here's a summary of our learning in this session. Finding the probabilities of an event after identifying the distribution. Fitting a given distribution for the given frequency distribution when parameters are known or unknown.